Oh, good. You can go ahead and we'll just let you start. And then after you're done, you can stop your share and I'll load up the rest of the slides for the agenda.
Okay, that sounds great.
Great. And we'll just wait maybe a minute or two more see if we have anyone else who will be joining us.
Okay. And I'm aiming for somewhere in the, I haven't gone through all these slides before, but I'm gonna aim for the 20, 25-minute mark.
Oh yeah, absolutely. And then we'll also do Q&A after. Perfect. And we'll go from there.
Okay, that sounds great.
So there's a person with a 360 number. Is that a call-in for audio, or is that a separate person on the call?
Hey, it might be me. This is Cheryl Nemi. I'm from Ecology.
Oh, okay.
I just called in.
Great. Okay, thank you.
All right, thanks.
Just helps us with our notes at the end. Make sure we identify everyone who is on the call. How are you today?
I'm doing fine. Thanks for asking. Everything going good where you are?
Yes, absolutely.
Okay, great. I'm looking forward to the presentation.
Me too. And it looks like we have you as well, Robert?
Yes, I'm here.
Great. Like I said, we'll just wait 1 or 2 minutes more, hopefully, because we had to reschedule. I know there were a couple of people who were planning to attend who just weren't available today. And I think for this particular meeting, I'm going to go ahead and make, if it's all right with you, Alissa, the recording available afterwards so that people who missed your presentation can catch that.
Fine. I can also send you a PDF of the slides if that'd be helpful.
Okay, yeah, that would be great. And I'll make sure that's all available for download.
Great.
Okay, Alissa, if you want to just go ahead and get started, that would be fantastic.
Sure. Well, thanks, everyone. It's nice to meet you over the interwebs. My name is Alissa Cordner. I'm an associate professor of sociology at Whitman College in Walla Walla. And thank you for bearing with me with the cancellations. In January, my daughter was sick, and then last week I was sick and had zero voice, and so it wouldn't have been a very effective presentation. I still have a little bit of a cough, so I hope you all can hear me, and then if I have a coughing fit, I'll mute myself briefly. But I'm going to present today on a collaborative research project that I have. I'm the co-director of the PFAS Project Lab, which is based at Northeastern University's Social Science Environmental Health Research Institute, or CERI, and Phil Brown is the co-director of the lab. And we've been working on PFAS issues. So here's, let me see if I can. Trying to make sure I can, there we go. So here's our full research team. Phil and I are the co-directors. We have a number of collaborating faculty and research scientists at Northeastern, at Rhode Island School of Design, and at Silent Spring Institute, also here at Whitman. We have a postdoc, multiple graduate and undergraduate students, and we also collaborate closely with a number of community organizations. And this started in 2015 with our first NSF grant to study the social and scientific discovery of PFAS compounds. At the time we were writing the grant in late 2013 and early 2014, there was relatively little attention to PFAS. This was before the UCMR data was released, before the testing had even concluded, before Department of Defense released all of their testing data. So there wasn't a lot of, certainly not much advocacy attention, not nearly as much regulatory or scientific attention as we see today. And so since that time, we have grown our website, which is pfasproject.com, into a website that has almost daily updates of PFAS-related news stories. And we also have our contamination site database, which I'll talk more about towards the end of the presentation. So just some very quick background on PFAS. I imagine that folks on the call are relatively familiar with this class of chemicals, but just so that we're all on the same page, we used to talk about PFAS as PFCs, and the chemicals that have received the most attention, both from a scientific and a regulatory perspective, are PFAS and PFOA, which are both, people talk about them as long chains, meaning that they have multiple carbons, a very long carbon chain length. And PFAS tend to be highly persistent in the environment and in human and animal bodies. We know that most PFAS, especially some of the long chain and legacy compounds, are extremely bioaccumulative, and there are concerns about toxicity. PFAS are widely used in consumer and industrial products. Many consumer products that we're familiar with, of course, the Teflon and nonstick cookware, any sort of high performance fabric that repels water or grease or stains, but also uses like dental floss and ski wax. And they're very, very widely used in industrial applications, all kinds of manufacturing processes. And then of course they're used in AFFF, aqueous film forming foams, which are used to fight certain types of liquid fires. An AFFF foam are for Class B fires. These are things like flammable fuel or alcohol-based fires. So PFAS get into the environment through multiple potential exposure pathways and use pathways. AFFF foam has been a dominant source of PFAS contamination, especially around military bases and fire training centers. One point I want to make that is relevant throughout, throughout our work and throughout this presentation is that there's a lot of known sites of contamination and a lot of known sources of contamination, but in many ways we are shining spotlights in some places and finding PFAS in those areas. That does not necessarily mean there aren't other sources of PFAS contamination that we just don't realize are widespread sources because they haven't been studied. And one of those sources is the wastewater treatment and biosolid application to farmland. So sludge application to farmland may be really a very widespread and significant source of contamination that just hasn't been studied as much. So in addition to the firefighting foams, there's also contamination near production facilities, either facilities that actually produce PFAS. So you see here on the slide photos of DuPont's Washington Works plant, but also sites that are also manufacturing facilities that use PFAS in their production and supply chains. Landfills can also be a source of PFAS contamination if the landfill leachate gets into the environment. Wastewater treatment plants and biosolid application I just mentioned. Septic systems may also be a significant source because these compounds are so widely used in consumer products and because over 98% of US residents carry levels of PFAS in their bodies that can then enter into the environment through septic systems. So I mentioned persistence a moment ago. These compounds are extremely persistent. You can see, for example, compared to bisphenol A, which we can metabolize quite quickly in a matter of hours, some of the long chain compounds have half-lives of more than 5 years. So they stay in the body for years. Even the short chain compounds can stay in the body for many days at a time. And so this level of persistence is really concerning. When we think about this as this class of chemicals, it has a very long history of discovery. So on the one hand, there's been a lot of recent attention to PFAS, but we have over 70 years of production knowledge. Some of these legacy compounds were developed in the 1930s and 1940s. We also have well over 50 years of knowledge about toxicity. So in 1961, DuPont found evidence that some of their, that PFOA was toxic to the liver in animal models. In 1962, they found their first hints that it might be toxic to humans in populations of their workers. In 1976, 3M found PFOA in workers' blood. And in 1980, 3M found that PFOA caused rare birth defects in rats that were similar then to birth defects that were discovered in the children born to women workers in DuPont's Teflon unit. So we have many decades of knowledge that at least some chemicals in this class are highly concerning in terms of toxicity. But it really has, the action has not happened that quickly. Some of the main areas of social discovery were related to DuPont's contamination of a PFOA waste site that they purchased from the tenant family. And they purchased the land in 1980, dumped tons of PFOA waste on this landfill after agreeing in the purchase agreement to not use it for hazardous waste. And in the early 1990s, the tenants noticed environmental impacts on their farm, including dying wildlife, and then the deaths of their entire cattle herd. They tried to work directly with DuPont and were unable to do so. And so they pursued a lawsuit, and you can actually see this story portrayed by Mark Ruffalo and then other supporting characters in a major motion picture, Dark Waters. So this part of the social discovery, again, we're talking 1980, 1990, this is going back decades, and this led to a major settlement by DuPont, both a settlement with the EPA for TSCA violations and a settlement with residents of the Ohio River Valley to do a health monitoring study that led to the C8 health panel, which took place in the early aughts into the early 2010s, was an epidemiological study of 69,000 residents that made clear associations between PFOA exposure and multiple health effects, including thyroid disease, kidney cancer, high cholesterol related to liver effects, ulcerative colitis, pregnancy-induced hypertension, and testicular cancer. Other areas, other studies have made links between additional health effects, including additional forms of cancer in humans. Right now, people are especially interested in all types of hormone disrupting effects, and including immunotoxicity in children. So there are multiple studies, including a study that we're part of that is looking at vaccine response in children. So, and I will say that a lot of this research has focused on PFOA, and a smaller body of research has focused on PFAS. And so there's less evidence, there's less epidemiological evidence of health effects, but there's a significant body of evidence showing similar system effects across the class of chemicals. So even if there isn't overwhelming epidemiological evidence for every individual PFAS in the class, and I should have mentioned there are almost 5,000 chemicals in this class, according to the most recent estimates. But I think that one came from OECD. So this is a huge class of chemicals. Certainly there is variation in the chemical structures and in how those chemicals behave, but there's also significant reason, as I'll talk about in a minute, to treat these chemicals as a class. The one way that folks have responded to information about the widespread exposure and persistence and toxicity of PFAS is through drinking water regulation, This has been a focus of our work as well, trying to understand, number one, why there has been such delay in drinking water regulation, and number two, what accounts for the uneven levels of health advisories and drinking water levels. So in UCMR 6, the Unregulated Contaminant Monitoring Rule through EPA's Clean Water Act, there were 6 PFAS that were included, and EPA has announced that they'll include additional PFAS in the next round of UCMR, but the testing won't take place until 2023 to 2025. Again, just focusing on how, as we learn more about these chemicals, we become aware of multiple potential exposure sources. So industrial production and disposal, for example, the contamination of the tenant farm were the original sources of knowledge. There's also sites, for example, near Decatur, Alabama. And then we have UCMR testing, and then we have a pretty comprehensive testing at Department of Defense sites that was released in March 2018. There's also concern about food, both through sludge and also through food packaging. As I mentioned, contamination of human bodies is very widespread. And the nationwide NHANES biomonitoring studies show that 98% of the population have multiple PFAS in their bodies. And so our research group has argued that a class-based approach to PFAS is needed. So it's not sufficient to merely replace legacy long chain compounds with the alternative next generation compounds, because there are similar concerns about toxicity, bioaccumulation, and persistence. Even if some of these replacement compounds are potentially less bioaccumulative, they remain persistent, they remain toxic. And what we have also heard from folks who work closely with industry partners is that because in some cases the chemicals are not as, their performance is not as efficient, you're using a higher volume of these replacement compounds, and so you can end up with higher levels of exposure. So for example, what we've seen is a pattern of regrettable substitution, where as PFAS levels, this is again drawing on NHANES data, as PFAS levels have declined, we've seen a corresponding increase in PFNA. Levels in human bodies. And so again, just raising concerns about this idea of regrettable substitution and needing instead to turn towards a class-based approach for this class of chemicals. So we have seen a tremendous growth in policy and regulation. So there's for example, a national health study that was funded through the NDAA that is taking place at, I want to say 6, might be 7 sites around the country, trying to identify health effects associated with PFAS. And again, including PFAS in a future UCMR. However, there's also been a real sense that even if EPA is doing something, they're moving so slowly at the federal level. There are real concerns about adequate regulation of this class of chemicals. So one of the things that we did in our research group, this is a publication that came out last year in the Journal of Exposure Science and Environmental Epidemiology, is to look at the different guideline levels for PFOA and PFAS in drinking water. At that time, we identified 8 PFOA guideline levels and 7 PFAS guideline levels. I should note that these levels are already outdated. A number of states, as I'll talk about in a second, have developed additional levels. But we wanted to highlight the variation in drinking water guideline levels when supposedly all of these states and the US EPA are drawing on similar bodies of evidence. They're drawing on the same data, but they're arriving at very different conclusions. And we looked at differences in how the different drinking water evaluations looked at exposure assumptions. For example, how much drinking water does a person consume? Who is the target population? So who's the vulnerable body that needs to be protected? Is it a breastfeeding infant versus a lactating mother, for example? And we also looked at which health endpoints states considered. For example, did they consider things like mammary gland toxicity, or did they focus on liver effects? And we found, again, this tremendous variation in guideline levels. And since then, our research quickly became outdated. I guess that's a good thing in this case. And so we have seen a number of states propose or enact MCLs or other advisory levels that are much lower than the EPA's health advisory of 70 parts per trillion. And Washington State, for example, in December proposed a state advisory level of 10 nanograms per liter of PFOA and 15 nanograms per liter of PFAS. These levels are much lower than the 70 parts per trillion PFOA PFAS combined for the EPA's health advisory level. We would also highlight the importance of public and activist pushback on these high proposed MCLs that in some cases, for example, here we see New Hampshire has led to lower levels. So the proposed MCLs for all 4 of these PFAS were much higher, at least twice as high as the MCLs that were eventually promulgated. And members of the public, scientists and activists pushed back on these high levels, saying that they did not reflect the best available science and the need to protect public health. So what does this mean for our current framework for PFAS regulation and activism? So assessments by multiple states and academic scientists show that the EPA's health advisory level is not sufficiently protective. The EPA has indicated it is interested in potentially exploring the development of an MCL, but this would be years in the future. There are also concerns that other parts of the federal government might push for even higher levels. For example, we've heard that Department of Defense would like to use 380 parts per trillion as the cleanup level for groundwater. And there are real concerns that those levels are not sufficiently protective. We would also note that the patchwork of state levels and legislation leads to very uneven protection, where residents in perhaps more environmentally progressive states might have safer drinking water than people in other parts of the country. We've also been paying attention to action by retailers and product manufacturers. So this is drawing from a paper we published in New Solutions last year about manufacturer and retailer action removing PFAS from consumer products. So for example, we've seen, the retailer Co-op Denmark removed all microwave popcorn from their shelves until producers could develop a popcorn bag that did not contain PFAS. And remarkably, even though industry said that it wasn't possible, very quickly companies did develop a microwave popcorn that was PFAS free. We've also seen action here in Washington State on PFAS in food packaging and looking at assessing where PFAS is used in food packaging, whether there are safer alternatives, and then pursuing restrictions when those alternatives are identified. The coalition of folks working on PFAS is really broad, and we talk about this as a multi-sector alliance. So it's not just environmental activists and clean water folks and health folks. It's also military and veteran, active military members, veterans. It's educators. It's lawyers, and there's been a real prominent role for litigation in the PFAS story. And additionally, they're targeting some really non-traditional targets of social movements. So if you think about social movements, typically pushing against regulatory bodies and legislative bodies. Here we also see, for example, that PFAS activists are targeting supply chain manufacturers. They're targeting water utilities and municipal water systems. And they're also pushing back against responsible parties, saying that whoever did the pollution should be held responsible for cleanup and for providing clean water. We've also seen some states pursue litigation directly against chemical manufacturers. So multiple states have sued PFAS producers, especially 3M and DuPont and Solvent, for example, in multiple states. Although none of those have been, lawsuit in Minnesota was settled. Other lawsuits remain ongoing. So our research with the PFAS Project Lab, we use a mix of qualitative and quantitative research methods. We've conducted over 90 interviews with the full range of folks who work on PFAS, and we're still conducting interviews around the country. We also do participant and non-participant observation. We gather historical documents, and then I'll talk in a moment about our quantitative analysis of PFAS contamination. And I'll just highlight here at the bottom of this slide is the website Toxic Docs, which is a free, publicly available archive of online documents that includes a lot of PFAS-related material now. It also includes a lot of material from other chemical cases. So in addition to our academic work, we also do a lot of engaged work as well. So we work closely with community groups, especially those groups that represent people directly impacted by PFAS contamination. So we partnered directly with Testing for Peas, which is based in Portsmouth, New Hampshire. We worked with Breast Cancer Coalition, Toxics Action Center. We've helped groups do testing for their own drinking water. We've helped link them with experts who can assist with community advisory panels, that kind of thing. We provide very frequent responses to residents of impacted communities. We have a Gmail address, which is pfasproject@gmail.com, where people can email us for general information, and we can sort of act as that network to connect people to information that they might not have. We also do a lot of engagement with especially state governments. So for example, I serve on the on Washington's Ecology's PFAS action plan, the Chemical Action Plan, or CAP. We've written letters in response to proposed MCL levels in various states, multiple states. We've testified in front of legislators, and we have provided various feedback to proposed PFAS research projects through ATSDR and other states. I want to now talk a little bit about our contamination site database. So this started in 2016 with just a handful of sites. We had just started our first NSF grant, and we wanted to understand where PFAS contamination was happening. And it currently has over 300 sites in the US. And in addition, it has almost 100 contaminated drinking water systems. So every site in our tracker is linked to a particular source of contamination. I've pulled up here just the first 3 from Washington State, and you'll see the Airway Heights contamination from Fairchild right at the top there. And we try to present as comprehensive of information as possible. So we have, for example, the highest combined PFOA and PFAS measurement, because that corresponds to, for example, to the EPA's health advisory level. But we also provide information about all the other testing data that we can find. We include information about where the contamination occurred, when it was discovered, information about community responses, for example. And this database is available on our website, and we also make it available to researchers and residents and activists who want to download the full database and use it for their own work. And our database is being used by the PFAS Exchange website to plot every site you can see here is one of those known contamination sites. You'll see, for example, the cluster in the state of Michigan. And here again, part of that is because there is a lot of PFAS contamination in Michigan because of industry. 3M had a lot of sites, and other related companies had a lot of sites in Michigan. However, Michigan was also the first state to do systematic testing of all of its drinking water sources. And so there's just more data on contamination in Michigan. It doesn't necessarily mean that Michigan has a lot more than other comparable states would have, but their testing data is just a lot better. So we expect to see, as other states develop their MCLs, require ongoing systematic testing, we expect to see more sites of contamination coming online. We've also organized 2 national conferences focused on PFAS. The first was in 2017. And both of these have taken place in Boston, Massachusetts. First was in 2017. It included a keynote by Dr. Birnbaum, who was, she's the now retired director of NIEHS. Also Rob Bolott, who was the lead attorney who helped the tenant farmers with their class action lawsuit against DuPont, and Ken Cook, the director of the Environmental Working Group. That first conference had over 140 attendees with 2 full days of presentations. And our 2019, and then coming out of this conference, not only did we see new networks between scientists, connections between regulators and drinking water folks with scientists and activists, we also saw 2 really important outcomes. One was that residents and activists from PFAS impacted communities came together and formed the National PFAS Coalition, which is the only coalition of PFAS activists in the country. We also saw some direct attention to a new location of PFAS contamination, North Carolina. So Sharon Lerner was in attendance at the conference. She's the reporter at The Intercept, and she was in attendance at the conference when this new data was presented. And she wrote this, this piece in The Intercept on June 17th. And I want to say it was June 25th. It was something like a week later, North Carolina really started to pay more attention to PFAS, at least in part because of this media attention. So we held a second conference in 2019. This one was even bigger. We had over 250 attendees, and we actually had to have an overflow room because there wasn't enough space. We had 3 days of presentations with a number of notable PFAS experts, and we also had a lot of representation from impacted communities around the country, and a keynote this time from Gina McCarthy, former EPA administrator. So I'll end here with a slide showing our publications. If you're interested in any of these, I'm happy to send them to you if you don't have access. These are all PFAS related. And then my email is here on this last slide. So thank you so much. I look forward to your questions.
Thank you, Alissa. I'll go ahead and just start off questions and then happily open it up to everyone.
Mm-hmm.
So you, I think, talk about in the book and from the research that it's clear that science is being used by different stakeholders in different ways. Do you mind speaking a little bit to that? Because I think we, while we're dealing with a different chemical of concern, we have a very broad stakeholder base as well.
Mm-hmm. Yeah. Absolutely. I think there, you mentioned the book, so I have a book called Toxic Safety that focuses on flame retardants. This is a chemical I studied in a previous research project. And I use the case of flame retardants to argue that when it comes to environmental health controversies, every single stakeholder is going to use science to advance a non-scientific claim. So they're going to use research and evidence, and they're going to strategically translate scientific evidence to advocate for policy changes in certain directions, or advocate for increased attention to this area and decreased attention to this other area, or advocate, for example, in the case of industry, they're often using science to advocate for the preservation of markets. I think that when it comes to then, working with diverse groups of stakeholders, it's really important to come to that working relationship, acknowledging that although science is about the quest for information and about improving our understanding of complex systems, scientists will be the first to tell you that uncertainty is also fundamental to the scientific process. And so there has to be a recognition, as I've been presenting just today, I myself have been translating a very complex and dynamic field of PFAS research and making some claims based on how I view the weight of the evidence on PFAS, but other reasonable observers might come to different conclusions about that same weight of the evidence. So I think that's the first step in working with diverse groups of stakeholders, is recognizing that, number one, science, that uncertainty is part of the scientific process. And therefore, that uncertainty, even though it also creates space for the scientific method to function, it also allows science to be used strategically for different goals. So I guess my second piece of advice then would be for everyone to, we would love for everyone to just be upfront about what their goals are. So my goal as an environmental sociologist is to develop research that improves public health and environmental and social justice. So that's the bias that I bring to my research, and other folks are going to bring different biases, whether it's to their research or to their industry work or to their advocacy. People are going to have different biases, and so to the extent people will be open about those biases, that's great. I think it's also valuable for those of us who work with different types of folks. You can generally often understand what someone's goal or bias is going to be. And that can help you understand how they're going to be, translating the science, whether it's a translation in favor of public health protection or a translation in favor of market protection. Those are going to take you in very different ways, very different directions. Does that answer your question, Anna?
Yes, thank you. That's very helpful. So if Cheryl or Robert want to jump in, I have many other questions if you guys don't have them. So feel free to jump in, and then if not, I'll continue on.
This is Cheryl, I thought the presentation was really interesting. And what I'm trying to think of is just the history of that and how we've sort of seen a similar history with PCBs and how some of the lessons that you have learned and are currently learning with PFAS in your work, because it seems like you have a broad take on it, and you're looking at more social understanding, being included in that. Are there any recommendations or any kind of parallels that could help us work with iPCBs, given that PCBs have been just studied in and out for decades now. Yeah. So we're all aware of the issues associated with historic contamination, and even ongoing sources of contamination from sort of historic use. But now we have these new sources of iPCBs that we're learning about, and we're trying to figure out what to do with. But I think that isn't necessarily something that the public really knows very much about. So just any advice or parallels you could draw?
Yeah, I think it's a great comparison because, in many ways, PCBs and dioxins sort of, they made it possible for folks to think about chemicals as a class. Because there is so much tension to PCBs as a class as there should be. So I think there are lots of parallels here. Another parallel I see in terms of what you mentioned around the inadvertent uses, that I think that's also the case with PFAS, for example, and the sewage sludge application. So this is an area of scientific research and regulatory concern that's really not developed very well yet, is my understanding from talking to folks. So there have been two very notable contamination. There's one very notable contamination that we know is tied to sludge, and that's a dairy farm in Maine that had applied sludge to the fields that they used for their to grow hay for their dairy cows, and then also to graze the cows after the grass had been cut. And the farmers then had stopped using sludge on those fields, but it was something like a decade later, they had their milk tested and found such high levels of PFAS contamination because these compounds, like PCBs, are so persistent. And so then these farmers were unfortunately faced with euthanizing their cattle because they weren't able to sell the milk, and they weren't able to sell the cows for meat. They also weren't able to use the land because it was so highly contaminated. So I think there in that situation, you have a more obvious intervention in terms of cutting off the source of, well, let's not apply sludge to agricultural fields where the product's going to be grown for human consumption. But even that intervention has become very problematic in Maine because of the ways they designed the interim regulations, and then the question of, what do you do with the sludge? Then is it hazardous waste that has to be landfilled, or is it landfilled in a regular landfill? Just all those questions of disposal. One parallel I see with the iPCBs would be around again, just doing whatever you can to cut off that source. And I'm not nearly as familiar with the specifics of the Spokane PCB issue as I am obviously with PFAS. But my understanding is that there are still concerns about discharges and emissions from, for example, from the paper mill or paper company. And so it seems if we're taking, lessons from historic PCB cases and lessons then from flame retardants and PFAS, you want to do whatever you can to prevent those discharges, certainly into water systems, trying to think as upstream as possible. And I know a lot of the work that Northwest Green Chemistry does is about, thinking about green chemistry solutions and redesigning production processes, redesigning chemistries. And I think that is such important work because it's looking very far upstream. And then I think also there is just still that, pollution prevention piece too, that has to, there have to be controls on what companies are emitting.
This is Robert Mott. I have a quick question about that situation that you're talking about in Maine.
Mm-hmm.
Were they able to identify that the sludge came from a specific wastewater treatment plant, or was it from all of the wastewater treatment plants?
That's a great question. I don't remember if it came from a specific wastewater treatment plant. I do remember that the subsequent testing that I don't remember what their environment, I think it's Maine DEP, but I might have just the name of the environmental management agency. But the subsequent testing that they did found that virtually every single water system, virtually every sludge sample they tested was above the provisional level that they had developed. And so the contamination was really widespread. And this is what makes us think that that sludge contamination might be one of these major areas of PFAS contamination that we're just not aware of because people have not looked for it. They haven't tested for it.
It's an interesting point, because in part I'm just doing this as a guess because I haven't lived in Maine and studied Maine, but I wouldn't be surprised to discover that there was a regulation or a law requiring or promoting the idea that the wastewater treatment sludge be applied to agricultural land.
Absolutely, I think that was the case. There were incentives,
and so the unintended consequence of a law, providing a solution to a problem. The problem was, what do you do with the sludge?
Yes, absolutely.
That they didn't, but it wasn't looking at what the potential implications are. A California example that I'm aware of, for instance, is that there was a fuel additive, methyltebuthyl ether, that was suggested as an alternative to tetraethyl lead. And it was mandated that it be used in fuels being sold in California. It worked out very well until they discovered that the underground storage tanks used for gasoline leaked. And methyltebuthyl ether doesn't readily decompose in the environment, thereby, contaminating the water. So the mandated solutions sometimes, are what are leading to the problem, not the actual, quote, contaminant itself.
Yeah, absolutely. And I think that both of those cases really point to, you know, the larger reason why we end up with, you know, one emerging contaminant, so quote unquote emerging contaminant after another, is that there isn't adequate, you know, evaluation of chemicals toxicity and exposure potential before they are really widely used in consumer and industrial processes and allowed to contaminate and be released into the environment. That we don't have those regulatory safeguards in place before production and use is so widespread. And so then you end up with these unintended consequences. And certainly they're not, you know, DuPont and 3M they didn't develop these compounds trying to make really PBT compounds, but because there aren't sufficient regulatory safeguards on the front end, you can end up with chemicals being really widely used to the extent of, you know, contaminating over 1,000 drinking water systems around the U.S.
Well, don't forget that there's been a lot of change. You know, when whether you're talking about you know, BPA or PCBs or the PFAS concept, there's been a lot of advances in analytical chemistry since those were invented. And so people weren't necessarily aware of where they were going and being released into the environment. Here's an idea to think about. Sometimes the impediment to cleaning things up is that industry and, well, first off, the assumption is anybody that worked in industry doesn't care for the environment, which is kind of, you know, an odd concept because they really, you know, some of them really do. Anyway, they end up being on opposite sides of an argument, leading to no solution. If what the regulation said is that the water leaving your plant has to have fewer chemical substances, you know, rather than, you know, for instance, making it like a TRI list where there's specific reportable substances, what if it was report the substances that are released?
Right, because there are analytical
next year they should be lower. Next year they should be lower than the levels that they were this year. And the downstream users, you know, if the water coming into your plant, you know, for instance, from the Spokane River, if the regulation is about all PCBs, then if the water leaving your plant, whether you're the city of Spokane trying to provide drinking water, or whether you're Inland Paper trying to provide processed water, or whether you're, you know, Kaiser Aluminum just worrying about, you know, groundwater seepage, if the water leaving is cleaner than the water coming in, then that's progress. And you should work at the concept of what can you do from the point of view of progress rather than looking for you know, doctrinal purity.
Yeah, and I definitely appreciate that. And I would just add that progress should be, you know, moving and achieving public health protection. So there needs to be a goal that's, you know, that is established and met relatively, you know, in a timely manner, that doesn't just get to cleaner water, but gets to water that is protective of public and environmental, public health and environmental needs.
But even though in the case of things that are known to be hazards, okay, that have been known to be hazards for decades, in some cases centuries, we've allowed, you know, if you will, government got off the hook. For instance, the aerochlors were banned, and you know, it went from being hundreds of thousands of kilos per year to being 0 kilos per year in about a 5-year period of time because they were banned. And the government went away very happy. because they made the environmental community happy because they banned aerocolors. But nothing was done about all the installations that contained aerocolors. The same thing with lead paint, by the way, and the same thing with asbestos. So everybody went away warm and fuzzy because we solved the problem. Well, we didn't solve the problem. In fact, we didn't even do anything at all to address what the major exposure circumstances were for most people with those three circumstances. And they went away and we've ignored it. And so now decades later, after not being able to sell lead paint, we still have children, especially in large cities. And actually, it's very odd because it's large cities and rural communities. The rural communities because it's old buildings, the large cities because it's old buildings that are being exposed to lead paint. You don't have it in suburbia because all the houses are new and were constructed after the lead paint was banned.
So I have a.
So what's
Go ahead. I'm
so it
sorry.
wasn't an academic, it's not an economic thing. It just happens to be an age, in that case, it happens to be an age of construction, issue.
Right. And so then I think the point that ties all these examples together is just the need for public health protection. So certainly there was an oversight there in not thinking about lead paint as a significant source of contamination. But the overarching message to me is still, let's make sure that things are safe for public health and environmental needs.
So I have a question about you talked about retailers and manufacturers taking action. And we'll be presenting at the Sustainable Packaging Coalition twice this year around the iPCB issue and trying to raise awareness. Do you have any takeaways you could share with us about how brands make voluntary changes? Because I noticed, you had the slide up that talked about the states had different levels, and we see that all the time, obviously, with other chemicals of concern. But we're often trying to look at, are there sort of voluntary limits that can be set, or substitution coming in earlier? So if you wouldn't mind just speaking a little bit about that, it would be very helpful for us.
Sure. I have a couple general thoughts on that. One is what we did for the paper looking at retailer action was we focused on a particular advocacy campaign done by Greenpeace that was targeting clothing manufacturers. And what we found was that of the companies that had said publicly that they were going to meet, sign on to this campaign, there certainly were some that seemed to be following through, and then for others it seemed to be purely lip service. So we saw this real range in how effective this type of retailer voluntary program, and it wasn't a regulatory program, it was them voluntarily signing on to this advocacy platform. But there was a real range there. And so one of the takeaways in the paper was, a need for some caution around relying on voluntary solutions, that there certainly can be movement that happens with voluntary programs, especially around, especially by industry sectors that might be particularly responsive or you might say vulnerable to market pressures. So for example, we saw that with PFAS and also with flame retardants in the baby product and like child furniture and car seat sector. So there's a lot of testing of those products, a lot of public advocacy around those sectors. So it's sort of, there might be specific sectors that are especially vulnerable to that type of market pressure and might be more likely to take meaningful action, especially if there is some sort of, maybe I'll call it like a forced transparency. So a lot of these campaigns have relied on annual testing of these products to see, are there in fact still, brominated flame retardants in this car seat or not? And so that type of forced transparency has been perhaps more effective at pushing for that voluntary change. I think that companies also appreciate the ability to present themselves as leaders in areas that matter for public attention. So we've seen in some of the labeling of PFAS, we've seen, for example, labeling of does not contain PFOA. Unfortunately, that's not a very meaningful label anymore because there isn't much ongoing manufacture or use of PFOA in the US, although there is some in other parts of the world. So I think sometimes there can be that sort of self-differentiation and labeling that companies can do. I think that probably is challenging with PCBs because they're not as much on people's radar at this point in time. People think about PCBs as a problem that used to be as opposed to a problem that is still very pressing, which is, I think, is unfortunately a challenge for the work that you all are doing. But I think another lesson that we have taken from, both from the flame retardant and from the PFAS story is that companies are quite capable of reformulating when they think they need to. So I mentioned the microwave popcorn in Denmark story, and that sounds like a small niche industry, and it certainly is a niche industry, but it's also, microwave popcorn is a huge industry, and so for the industry to go from every single microwave popcorn bag contains PFAS and there's no way to produce microwave popcorn bags that don't contain PFAS to within less than a year of being pulled off the shelves, they had a completely reformulated and successful product. So I think that type of innovation is really possible, whether it's motivated by, in that case, the complete loss of a market. That's a pretty strong motivation. But there can also be other types of motivation, whether it's incentives through the form of grants from regulatory agencies or recognition by those regulatory agencies. I know the federal EPA has a bunch of different awards they give out for, for sustainable practices, things like that. So I think all of those can be effective. And then I think one of the takeaways that we see and not just in environment, not just in the case of specific classes of chemicals, but more broadly in environmental sociology, is that if you want to create widespread change, there typically does need to be not just individual action by consumers or voluntary action with part of an industry sector, but there does have to be some sort of regulatory action that supports or backs that up.
Thank you. As we
I'd like to offer a suggestion on the strategy as well. Sometimes there's a focus that, with the idea that if we approach the industries at a high level, like the CEOs or the chairman of the board, that publicly traded companies, that would be an effective strategy. I actually think a more effective strategy would be, what you want to find is in that sector, the largest national company, or the largest regional company that's privately held, and convince them, because a privately held company can make changes essentially instantaneously. We had an interest in an example I'll give you is in 1983, I think it was, Milliken Corporation, big textile company down here in South Carolina. Roger Milliken, the owner of the company, he decided that they were going to quit using typewriters in the company. And they were going to quit using dumb terminals connected to mainframe computers. They're going to use, PCs for everything, and then the PCs were either going to be directly connected to printers, or they're going to be directly connected to mainframes as needed for people to do their jobs. And he made this change in like 3 months for his international corporation, because You know, he just went in, they picked up the typewriters and they took them away. They took away the dumb terminals, and they left in place the PCs, and the implementation was much quicker. When I was at the University of Idaho, the second example I'll give you is Washington State was trying to sneak up on the metric system for transportation. And so they would put in dual, signage, miles per hour and kilometers per hour. I think a more effective strategy would have just been to change to kilometers per hour. And people would have figured out in a very short period of time, what 62 kilometers per hour or what 100 kilometers per hour meant, meant 62 miles per hour. And, trying to sneak up on change is sometimes not the best strategy.
Thank you. That's very helpful. Does anyone have any other questions for Alissa really quickly before we wrap up?
I'm happy to answer things
Yes.
over email as well.
Actually, this is Cheryl. And Robert, I thought that was a really interesting comment that you made about going to privately owned companies, maybe at a subsequent meeting, because I know we're hitting 11. But I'd like to hear maybe how that could work with iPCBs, whether there's any inroads there.
All right. Well, I think it's a universal idea. It would be applicable to essentially, quote, any social concern. If your major one of your major competitors does something that puts pressure then, on the other companies. And especially if it's one of your major regional competitors, it's difficult to argue that something's not possible if they're already doing it.
Yeah, I guess I'm trying to figure how that fits into the information, all the chemistry information that I learned about at the iPCB workshop in Spokane in October. And there, it seems like, reducing PCBs in the inks or dyes and pigments seems like it's a real chemistry issue, and so I didn't come out of that meeting seeing any real clear paths forward, although they may have been there and I just wasn't picking up on them, and I guess that's why we're working on it now. But yeah, how that development could work, or maybe just change in products that are used. So maybe we could talk about that another time. I think that's really interesting.
Okay.
I should run because I teach pretty soon. So thank you all. It was nice to be able to share our work with you. And again, I'm happy to continue this conversation over email or send you any of our publications.
Great. Thank you so much.
Thank you. It was really interesting.
Great. Thank you so much.